Work report guarantees. The guarantees extrinsic, e.g. 136. It's a sequence of up to C, up to the number of cause items. Each item has a work report, a time, and some, well, not assurances, like, what did I call it? Credentials, okay. Some signatures, right? That's what they are. Signatures together with who is signing. Signature, validator index. So who is signing, and then their signature. And we can either have 2 or 3. Yep. Good. We require that they are ordered by core. That's what this thing says. Unique and ordered by core. Right, now, every guarantee, everything in the guarantee extrinsic, its signatures, its credentials, must also be ordered by validator index. Yep. Again, this just keeps things as consistent as possible between blocks. And all implementations just have to check that things are in order. And they can be guaranteed there won't be any duplicates. Okay. So let's go a little bit deeper. Right. Start with the easy one. XG is this string, jam guarantee. This is what makes up the context of the signature. On top of that, oh look, I've actually bothered putting the encode function in here. On top of that, we're going to concatenate that to the hash of the work item. Hash of the encoded work item, but I mean, obviously you have to encode it before you can hash it. That's the material that we're signing, that's the message. Who is signing it? Well, it's the ed25519 key of our key set, our validator key set, indexed by V. V, if you remember, that's our validator index. S is the signature, that's the thing that we're checking here. Okay, good. What is K? We're going to look at that in a second. We're also going to require that the core of the work package, so the core that the work package expects to be executed on, is the core that these guarantors are validated, the core that we are currently sort of considering. Yeah. The core that the validator is assigned to. So V is the validator index. We're taking this C, which is, we're going to find out is actually it's from G. Yeah, so it's this mapping of indices to cores. We're dereferencing that with V to get the core index, and we're checking that the work package is meant to be on that core. Yeah? So they shouldn't be taking random work packages from other cores and trying to execute them on their core, yeah? Obviously. We want to make sure that they're only executing the work packages that are meant for their core. This is important because the authorization system works on a core basis. Like you can't transfer authorizations between cores. Basically, this is Agile core time. When you purchase Agile core time, you purchase it on a core, on a specific core index. Good. Right. So C, as I mentioned here, is this first item, which from G or G star. K is the second item. K are the key sequence. So down here. Here, really, but yeah. This is where it gets defined. Good. And then we choose between G or G star, depending on whether we are in the same rotation period or not. For this, we need T. T is just basically the block index that this thing was constructed with, right? So when a guarantor is given a work package, or actually signs a work package, it in fact signs something, it puts it with the T, with this T, which is the time that it was doing it. So it's sort of like to let the chain know that it's like, these are the signatures. It's my signature, not this other guy's signature. Yeah, because it could be one of two signatures. Yeah, it could be one of two different guarantor sets. It could be one from the current rotation, one from the previous rotation. And so we need to know which one. That's why there's a T here. Okay. Good, good, good. So we know that the 25519 key of each validator signatures. Yeah. So there is a reporters set R, which is what this middle line is. This is useful. It's actually useful later on when we're talking about the statistics. So we need to know who worked, or what guarantors, what validators guaranteed, and how often. And so we use we re-annotating and doing all this sort of extra work to reanalyze the extrinsic is a bit of a pain. Didn't want to do that, so that's why I keep these sort of, I don't know, whatever you call them, intermediate results. But they're not really intermediate. They're sort of marker quantities. Capital W, capital R. Calculate them in one place, use them in another place. Kind of like wormholes for calculation in the grey paper. R is one of them. And what R is meant to be is, as I say, it's the reporters set. So it's a set of those guarantors that have reported something in this block. We want to know who they are because they get paid for it. Yeah? And we want to record it. So that any chain that wants to, or any subsystem that wants to identify who has been very helpful can check and reward them as it chooses. All right, so if a key being in R is implied and implied by, there existing some W, T, and A tuple in the guarantor's extrinsic, such that there exists VNS signature in A, such that K, the K that is in R or not, is equal to the ED 25519 key of our bold keys, which come from G or G star, subscripted by V, which comes from the validator index. So basically, we're just all this says is all of these keys here that we've used to check a signature, assuming that all the signatures check out. If they don't, then the block's invalid anyway. We're going to take all those keys and put them in R. Yeah. It's a bit of a long-winded way of saying that, but there's not, I don't think, a much easier way of saying it. Good. Okay. Now, we may also want to know the set of work reports in the present extrinsic E. So we just want to retain all the W's that we've guaranteed. So we're going to go through all the things we've guaranteed, take out the W term. We're going to call that little bold W. All the new work that's been pushed into the chain. We're going to use that in a second. So for all the new work, every new work item, every new work packet, work report that is coming onto the chain through a guarantee, we are going to make sure that either row double dagger, so this second intermediate row, after assurances has taken out all of these ones that are now been assured and they're ready to be accumulated, row double dagger for that core is empty. Yeah, so we've got space on the core. Or the time This could just as easily be tau prime. Or the time is at least the timeout. Actually, it's at least the time that the thing went in plus u. That's the timeout is this. Yeah. U is our time. Big U is our timeout, number of blocks, and P double dagger WC T. T is our the time of entry term for that core, the time that the core started being used. Okay. So we want to make sure either it's timed out or it's free. And as long as it's timed out or it's free, then we're going to do wherever, somewhere we're gonna associate. Well, I'm not going to skip too far ahead, but we're going to go forward. But this is a requirement. Also, yes, the work package authorization hash. So this is a hash, WA, is the work reports authorization hash, must exist, must be a member of our work pool, authorization pool for that core. So alpha is our authorization pool set, pool sequence. We're going to put subscript it by the core index to get the authorization pool for that core. It's the prior, right? So it hasn't been moved along yet. And we want to know whether the authorization hash was in that pool. This basically means the work package was authorized to be executed in this core at this time. Yep. This is crucial for Agile core time to work in Jam. You need to make sure that the work package, the work report, the work package transitioning to a work report was a valid thing to do on this core at this time. Alpha is the term of state that tells us what is allowed to happen on this core at this time. Okay. This actually presents a very interesting thing for block producers, because when guarantors are signing something, it's not really in their interest to sign something that when it gets on chain doesn't pass this check, right? If it gets on chain, doesn't pass this check, I mean, the block's invalid, so it's not going to be included on chain in the first place. So it's very important for a guarantor to believe that whatever the work package's authorization it hashes, that it will be in the authorizations pool for its core at the point that the thing gets on chain. What ultimately this means, I mean, if it's very simple and the pool is just full of these hashes, if there's only hash that's in the pool, it's got 8 hashes in the pool, it's unlikely to take 8 blocks before the thing gets on, and therefore it's a very good bet that it will be valid by the time it gets into on chain and this check gets done. But maybe that won't happen. Maybe there's only 1 of these hashes in the pool. And then it has to be concerned about the possibility that a work report will be done on the core, or has already been done on the core, maybe by another guarantor set, and is making its way onto the chain, but it just hasn't seen that block yet. And by the time this report gets onto the chain, that report will already have been on the chain, and this authorization will have been removed from the pool. It also has to check where in the pool this authorization is. If it's very, very close to the end, then it might fall off out of the pool to make room for more items from the queue by the time that the report gets to the chain. So there has to be a little bit of prediction going on, right? And it won't be perfect. Inevitably, if it's kind of like instantaneous core time, right? And if someone has just purchased one kind of sort of time slots worth of core, which means that this authorization hash only appears once in the authorizations pool, and you have 2 distinct guarantor sets, which we know there are for a single core, it's possible that neither one knows what the other one's doing, and they could both be guaranteeing work packages that use the same authorization hash. Inevitably, only one will get through. They could both submit it, The first one will probably presumably get through and it will take the hash out of the pool. The second one will arrive at a block author and the block author will say, well, it's not valid because the thing isn't in the pool. Get thrown away. It's no big deal. No one gets slashed or anything. It's just there's a bit of time wastage. And it's limited to just 2 validator sets, 2 guarantor sets. In general, guarantors should not be guaranteeing the previous rotation, right? They should only be guaranteeing the current rotation. We just want to make sure that the previous rotation's guarantees remain valid. All right, so we're going to specify the maximum total accumulation. Yes. Right, so within, for any given work report, we want to make sure that GA, which is our, right, I think this is actually fairly well worded, so I'm going to just say it. We specify the maximum total accumulation gas requirement that a work report may imply as GA. Okay? GA is the maximum amount of gas that is required to adequately accumulate a work report. Basically, it corresponds to the maximum amount of gas that a single core may use for accumulation. Yeah? Different to refinement, accumulation. Realistically, it's going to be about 10 milliseconds worth of gas, because we expect to execute the block in about 3 seconds, and we have about 300 cores. So it's going to be about 10 milliseconds. So that's about 10 milliseconds worth of gas. Now what we're going to do is we're going to take all of the work reports, look at their service, go into the service, and look at the minimum accumulation gas and add them all up. This M is the minimum accumulation gas for a service. If we add them all up, we're going to get the minimum required accumulation gas for the core, or for the work report on the core. And that must be less than, or it must be no greater than, this GA, which is the maximum amount of gas a core can process. Essentially what this means is, suppose you have a very greedy service that says, if I'm accumulated at all, I need all 10 milliseconds of gas. And suppose as a block producer, you include 2 different work items for that service. Now, to adequately accumulate, as far as that service is concerned, you would need to have 20 milliseconds. But you don't have 20 milliseconds. We'll have to limit it to 10 milliseconds so that the block's executed in time. So this is an error on the part of the block producer, of the work package producer, for building a work package that cannot possibly be accumulated in our limits. And it's up to the block producer not to include anything that's guaranteed this way.